There's nothing more frustrating than not knowing what's behind the wall when you're doing a do-it-yourself project. Ian, you have a solution for that.
Hi guys, this is the Wallabot. It's a solution that we have built based on our chip that is a 3D imaging sensor that is able to do endless number of applications. Starting with this one, for DIYers and makers, we can basically attach it to our phone using our application, and we can just scan the walls.
Effectively, you've created radar on a chip, right? So one of the things that's really exciting is you've opened this up to other people. So tell us about that.
So our 3D sensor has two production lines, two product lines. One is for makers and developers based on the Wallabot that you just saw. It comes with a rich SDK, and it allows makers and developers to develop their own applications. We are running, as we speak, a Huckster competition with more than 150 developers already participating and developing their own applications, and a wide range of B2B applications that are being used with our chip, not as a full product, but they are incorporating the chip into their own products. Their teams are developing their own software algorithms on top of our SDK, and the SDK and the capability of the 3D sensor is so rich that the number of verticals and the variety of those applications is very, very impressive. Even impressive to us. We are surprised, almost every day of where it can go. So we are talking about smart home activities, elderly care, healthcare, security, augmented reality, production lines, robotic vision, automotive applications, safety applications inside the car, not only a car radar, but also ability to track location inside the car itself and optimize airbag opening, for example, giving robots the ability to see through materials and sense things, robots that are going to be much more safe to when they co-work or coexist with humans. And this is the trend today with robots. They are becoming much more smart, and they need much more information to be able to perform their activities and not only be a dumb robot that is repetitive. So they need a lot more new information. Our information is fully private. We don't have any visual, and it works with any light conditions, and it gives also the ability to see through material. So for example, in the smart home, you'll put one sensor that will be able to monitor activity level of different people in the house. So if it's air condition, it can sense movements in the house and then compensate accordingly. If it is elderly care related, we can see if someone falls in the shower or behind the sofa and monitor their vital signs afterwards, because all of those materials are transparent to us and connected to maybe to our call center. The same sensor that is able to do all of that is also able to be a mouse detector, as you can see in the Wallabot. It can also be a smart alarm system that can monitor activity when people are asleep, because it can also classify if it is a human being or if it is a pet, or even seeing outside. So we can get an intrusion alert before someone gets in the house, but just getting close to the walls out of the house.
One of the things that's very powerful is you've created these signatures, so you can actually identify things like breathing, like heartbeat, like a dog versus a cat or versus a human.
Right. So this is really interesting. The way our sensor works is based on RF signals, and we emit a lot of radio waves. It's low power, it's safer, it's a tenth of a smartphone. We collect all of that. Our chip is really, really powerful. We are able to crunch all of the data of a 3D arena and grab out of it locations, movements, the standing, sitting and lying positioning, classification if it is a big person, a child, a pet, and If you know what you are looking at, you can take out of it endless signatures. So we can now demonstrate here, for example, augmented reality system attached to our sensor that is basically looking behind the wall. So let's take the camera here, the headset, and Laura. So you can see that there is a guy behind the wall, okay? We'll ask him to move from behind the wall. He is not moving. Can you hold the...
Yeah. Whoops. Oh, okay.
So you can hold the mask and I'll get behind the wall. Okay, so now the mask is looking at the wall, and another guy that just passed by.
And there's a slight delay, but yeah. So Ian's going to go behind the wall, and there he is. And they've put a representation of what a person looks like, which is demonstrating the augmented reality. Very cool. And so you're demonstrating this augmented reality to show where things are going and how people might be able to use this in the future, right?
Exactly. This is exactly the point. We have a very powerful sensor that is very generic. The SDK is very, very rich, and it allows a big new number of applications. So basically, we squeezed a very powerful radar into a very small chip that the miniaturization combined with the price point allows a new set of applications that were never possible before.
And it's about a 15-meter range, the way you've got it set up typically?
Yeah, the setup typically is for the 15-meter range, and also can see inside walls like dry walls, concrete, wood, etc. in the ranges of up to 4 inches, 10 centimeters, and which is really helpful even for not only DIYers but also professionals that are looking for pipes, wires, leaks, humidity in the future. All of those are working today in our labs. The product by itself is providing wires, pipes, even non-metallic, holes. No, it's very powerful.
So one last question, what frequencies are you using?
So we are using ranges of the 3 to 10 gigahertz. Okay, for reference, Wi-Fi is 2 and 5 gigahertz. So this is the same bands.
It's unlicensed, I assume?
No, it's ultra wideband. Okay. It's not ISM.
Oh, okay.
Because we are sending.
But you're able to use it in an unlicensed mode, right? Or
we can also use it in unlicensed mode. Someone can develop their own application on top of it in unlicensed mode, but the power of the solution is the ability to transmit in the full range of frequency and collect all of that at once, and then we get a lot of information, not only that, but also combining that with the ability of manage up to 24 antennas with the same chip. So we get not only a wide range of data, but with a lot of antennas in parallel. It's a very, very
I guess the core part of my question is there's no licensing. Like, so if you're an OEM manufacturer with your chip, they don't have to get an FCC license to use it, do they?
Unfortunately, they don't need. They don't need. But we are regulated. We are selling Wallabot in US. We are selling it in Europe. We are extending it now. Extended it also to Canada. We are heading towards Japan, Korea, Taiwan, New Zealand, Australia, Mexico, and I'm probably forgetting something. So there is a product already licensed with that. So all the OEM's products is basically a derivative out of that. So we open the gate, and from there it's it's a license that someone needs to do, but this is not a headache. It's just a procedure.
Oh, excellent. Well, Ian, I appreciate your time and good luck with this. Thank you.